We got to write two equations for this one equation, and that's okay. I believe on the assignment, some of the problems, they're going to start in slope-intercept form. This one, of course, I purposely not started in slope-intercept form because not all of them will. So it says write first the equation in slope-intercept form. Oh, no, I guess not this one, but we want one that's parallel and perpendicular, but it has to go exactly through this point, which we'll show you how to do. First, we need to change that equation in the slope-intercept form. So let's go ahead and do that. I'm going to move it, though, over here so I can work with it. So let's go ahead and get to work. I'm going to get rid of that negative 5x by adding 5x's. That'll make it a 0. Just if I do it to one side, I got to do it the other side. So that will zero that out. I can now drop the negative 4y's, which equals, and I'm going to keep this in slope-intercept form order. So I got a 5x, and then I got a positive 12. So that's where that plus sign comes from, because the 12 is positive. If it were negative, I would show it as minus 12. Last thing here is I need to divide all the terms by the coefficient of y, which is negative 4. So that is what I will do. And that will become, I'm showing the 1 there, but it's going to become a phantom 1. So y equals 5 divided by negative 4 is negative 5/4. And 12 divided by negative 4 is negative 3. Again, we don't really care about the y-intercept here. All we care about for the equations of the parallel and perpendicular lines is the slope. So if I want the slope for the parallel line, the slope that is given is negative 5/4. So its slope has to match exactly the same. This slope will be the same, negative 5/4. The perpendicular line, though, I got to take that slope, negative 5/4, and now I must change it into its opposite reciprocal. So I'm showing the original negative 5/4. Now I will opposite reciprocate it, right? Which sounds like you guys had figured out right there. I apologize if I messed that up. But yeah, this is going to be positive, and then I flip that fraction. Now it's 4/5. So this is the actual slope we're going to be using. You know what? I'm going to use a different color just to kind of differentiate there. But this slope now is going to be 4/5. Okay, I'm doing that because I usually put the y-intercepts in purple. Okay, so we got to write the equations, though, in slope-intercept form. They've given us, well, I guess we found the slope ourselves. But we don't have we do not have the y-intercept. Now, again, I do have other ways to do this, but unfortunately, I think they want us to use point-slope form. So that's what we will do. So I'm going to set up point-slope form for both. There we go. So we got point-slope form, but we need slope-intercept form, so that's what we will do. I'm going to start with the parallel line. Of course, we know the slope is negative 5/4. And we have the ordered pair, which was given. We have an x value that's 5 and a y value that is 1. So I'm going to replace the x with 5 and the y value with 1. So now this shows as y minus 1 equals negative 5/4 times x minus 5. All we got to do now is simplify this so that it matches slope-intercept form. So I'm going to distribute the negative 5/4 here. So that's going to show negative 5/4 x. And then negative 5/4 times negative 5 should be positive 25/4. So I'm going to keep the fraction there. Then we still have we didn't do anything with the y minus 1. But now we can work with that minus 1 right there. So we will, by adding 1 to both sides. If you're worried about making those common denominators, don't. Just put that in the calculator, okay? That's going to give us 29/4 there, which is positive. But this will change it into slope-intercept form. So y equals now, we zeroed that negative 1 out. I can drop by negative 5/4 x. And that would just be plus the 29/4. This is the equation. I should probably box that in, right? This is the equation for our slope-intercept form that is parallel. And it will also go through 5/1. now you could check, right? If 5, 1 is actually on this line, it should make this equation true. And if you replace this with the 5 and then 1, you should get a true statement. Then let's go to the perpendicular line. Of course, the x, didn't mean to do that. The x and y values will stay the same, so my x value is still, use the same colors, still 5, and the y value is still 1. And the slope, we've already found the slope, right? We found it to be 4/5. So just filling in the rest of this equation, y minus 1 equals positive 4/5 times x minus 5. Okay, so it's exactly the same process we just did on that last problem. I'm going to distribute the 4/5 into the equation. So that'd be 4/5 x. And then 4/5 times that, I would show that as negative 5. That's going to give me negative 4, which again, you can put into the calculator if you need to. And that's not something you should ever feel ashamed about. But now I got y minus 1 equals 4/5 x minus 4. Last thing we got to do, just like we did on that last problem, is just add 1 to both sides. So this one's not too bad because there's no fractions, but hopefully you're letting the calculator do all that work for you. So now y equals, we'll just drop the 4/5 x. And then negative 4 plus 1 is negative 3. So we now have both. Yep. Parallel, perpendicular, and both these lines go through this point, 5, 1. Now, not that this is pertinent to the problem here, but this means if you graphed both these equations, I believe they intersect at 5, 1. That probably doesn't make a difference, though.